Hello and welcome to the April update from the TAO team. You're here with me, Fola. Without further ado, let's get into your Q&A questions for the month. All right, so the first question is from Thomas, and they ask, is TML's ability to process facts dependent on the amount of memory of the executing environment? I tested some codes on the TML playground with a large set of facts, and it gives me error and no results. Does it mean to say that the server does not have the amount of memory needed to execute the codes? Then it goes on to say, may I ask if my guess is correct, that if users need to execute this large set of facts, he either must run it with a high memory server, or he can rent Agoras processing power? Thank you.
Yes, the operational memory can be a limitation. So your problem with TML playground is most probably coming from the playground processing the results of the backend TML engine. So I don't think it's an issue in the TML itself. I'll address this issue in playground soon in the next playground version. Also, renting processing power or space will be possible after we build the mainnet.
Brilliant. Thank you so much, Tomasz. And this next question is to Ahad, and they ask, what do you mean when you say TML is p-space complete? The big O notation written in the white paper. Could you give us a layman's term? Thank you.
It is possible to classify programs according to how much resources they consume. We'd focus on two main kinds of resources. One is time, and the second is memory. Just like it is possible to classify programs this way, it is also possible to classify problems this way. There are problems that require certain time or certain memory or space. When we say space, we mean memory. And there are problems that we know that require at least a certain amount of resources, at least in the worst case. So a problem is a general thing. For example, multiplying two numbers. We don't give you the numbers. We just say to multiply two numbers in general. So for each program, there should be worst case, some structure of numbers, let's say without many zeros, so it takes more time or more space. Now, a problem is complete for a certain class described by complexity, by resource consumption, if any other problem in that class can be translated in using few resources to this kind of problem. So maybe the most common examples of completeness is NP completeness. So you can read about NP complete problems. There are a lot of interesting things to say about NP complete problems. For example, whether one famous NP complete problem is the traveling salesman problem. So you have points in the map, and you want to go through all the points by minimum distance, minimum total distance. So this problem is complete for NP. This means that other problems, even if they look completely unrelated, can be converted in short time to this problem. For example, if you have some numbers and you want to know if you can combine them using addition and subtraction and get zero. This is called the partition problem. The partition problem is also NP complete. So surprisingly enough, the traveling salesman problem can be converted to the partition problem and vice versa. Now, when we speak about resource consumption, as we said, it is about problems, and it is not about specific problems, it's about a class of problems. For example, in the traveling salesman case, the size of the problem is basically how many points on the map you want to go through. So complexity classes are typically characterized by how resources grow as a function of the size of the input. And moreover, we take even a more coarse-grained complexity class. We don't ask specifically how they grow, but which class of functions they grow. So for example, things can grow exponentially, and that would be exponential complexity class, exponential time if it is about exponential time, or exponential space if it is about exponential space. There is a connection between space and time complexity. So everything that can be solved in certain amount of space can also be solved in the exponent of that thing amount of time. One important class is things that can be solved in polynomial time or polynomial space. Polynomial means that if n is the size of the input, then there exists some power, some p, such that it never takes more than n to the power of p time or space. A problem is p-space complete if any problem that can, in principle, be solved using polynomial space can be converted in short time to that p-space complete problem. And this is what TML being p-space complete means. In fact, TML is not only p-space complete, it also so-called captures p-space. This means that not only that a conversion can be done, but also the conversion can be done using TML itself. It is not the case for some other p-space complete problems or complete problems in general. So any problem, anything that can be computed in polynomial space can be expressed in TML. And I hope that helps. For more, I really suggest you look into the world of NP-complete problems.
All right, thank you very much, Ahad. And this next question is from Frank Funk. And they ask, what features can we expect from the smart contracts of the beta planned for Q1 2023?
Well, what we expect to have is at least the proof of execution. So it is enough for one node to execute the contract and the rest of the nodes to get a short certificate of correctness of execution, in contrast to existing blockchains with smart contracts where all nodes have to execute all contracts, which is a big bottleneck for the computational capacity of the network. The computational capacity of the Ethereum network is precisely one home computer. The whole network, no matter how many nodes it has, it will still have computational capacity of one home computer, because all nodes do the same thing. The same computation is performed again and again. But once we have proof of computation, then with more nodes, proof of execution, then with more nodes, the computational power of the network grows, because each node can execute different code and give a cryptographic proof that the execution was correct. Another thing we expect to have is a network where you can pay for certain computations, for computation of BDD operations. One of the main characteristics of TML is that it converts its computation into BDD operations. And those BDD operations are, it's a common practice across the whole BDD world to store previous computations and reuse them. And in this sense, TML is no different. But what we expect for the upcoming network is that this caching of computations first will be stored across the whole network, and second, you will be able to ask some node to perform the computation for you for money, and then and that node will not be able to cheat because they will be able to give a short certificate that the computation is correct. There is more that we hope to achieve. We have the bottleneck of finding a developer that can implement all this, what we call a blockchain developer, but it's really much beyond the blockchain developer. So I really hope we make it to Q1 indeed. It's just very hard to find a developer, and we did find, just due to the problems in Ukraine, it affects us on this specific front.
Excellent. Thank you so much, Ahad. And the next question is from System D, and they ask, given the proof of execution mechanism, what is the minimum setup to validate transactions?
So in continuation to what I said before, there is a famous proof of execution algorithm that we are going to use, which is called the sum check protocol. So why don't anyone use this? Why people don't use the sum check protocol and give proof of execution already? Well, because it works only if you bring your computation to a very certain form. And in general, it would be extremely hard in practice to bring computation to that form. But TML, because it is implemented over BDDs, BDDs are already in that form. So we can readily use the sum check protocol and provide proof of execution for BDD operations, and in turn for execution of TML programs.
And this next question is from Meow Meow, and they ask, to help with the community seeing the forest from the trees, could we have someone give a quick high-level update of where we are in the next video, rather than just how every individual task is progressing? I know Karim already kind of does this, but it would be better if it was even more basic and top-down from time to time. Yeah, that's something we're actually going to work on at the moment. We are planning to have a separate overview video of the project in the form that you were talking about. So we're going to work on how we do that and really capture a bit more of an overview of the entire project. So that will come soon. And the next question is from Andrew Levine, and they ask, will the blockchain be written in Tau or something? Is it not going to be written in C++ or Rust?
The blockchain infrastructure, in particular, cryptographic primitives, including proof of execution, will be written in C++. But the, let's call it high-level algorithm of the blockchain will be written in the Tau language. The Tau language will not be TML. TML will be used only for the Internet of Languages and as execution engine for many other things, including the Tau language. And the Tau language will support the law of changing the law in different form that TML supporting, and in different form than explained in the white paper, and also support knowledge representation, and most importantly, to be a software specification language, because otherwise how can Tau be a software defined by its users? Being a software specification language is not something supported in TML, but the Tau language, which we worked very hard to come up with, can readily support this.
Brilliant. Thanks so much, Ahad. And this next question is a multi-parter, I tell you that. It's from Andrew, and they ask many questions. And the first one is, what does steps mean in info output? Presents various information about runtime, that was in brackets, in TML playground.
So in steps in TML playground, They are just steps of TML execution of the algorithm, how it's updating the database. In the TML updates the database in steps, and yeah, the playground shows when it reaches some step, it displays the information about that.
And question 2 from Andrew is, what is stored in each block of the blockchain of Tau chain? Is it cryptographic proofs or consensus of knowledge, opinions and ideas, or is it transaction related?
The most important thing to be stored in the Tau blockchain is the code of the next version or a reference to the code. Okay. Because Tau will change it itself, then you need to keep track in a decentralized fashion of what is the most updated code. And the only way to keep track on the most updated thing in a decentralized network is a blockchain. Of course, we will make sure that the blockchain will support many other kinds of data, including transactions.
Brilliant. And the next question from Andrew is, will we have a single blockchain, Tau chain, shared by all users, or will we have multiple blockchains where each created group have their own blockchain? Like one group who believes the sun is made of cheese has their own blockchain, Tau chain, and another group who believes the sun is made of hydrogen also has their own separate blockchain, Tau chain. Until such time, the group cannot maintain their chain since they have contradicting statements. And if they want to keep their Tau chain running, they have to fix the issue. But in general, if both groups are maintaining tautology, they can coexist together and evolve together. Or am I wrong in my thinking? Thank you for clarifying my thoughts.
Well, if we needed to have a blockchain for each different opinion, then we will have more blockchains than the number of people in the world. Of course, Tau is designed to separate people's opinion, especially when they don't affect the network itself. So, of course, people will be able to have different opinions without needing to fork the chain. In general, I don't see why multiple blockchains would be needed and why it cannot be done in one blockchain.
And Andrew's next question is, I'm trying to compare Tau Chain smart contracts 2.0 with the existing smart contracts 1.0 to better understand the difference between the two. In the old smart contract, miners solve some computational problem and only the lucky miner who solves it first will be rewarded. How is this different to smart contracts 2.0? For Tau Chain smart contracts 2.0, only one node is needed to verify Billy's modification of the smart contract. Will it be Billy who will do the verification himself? If no, then who? And if yes, then what is the job of the miners? Am I correct to think that in this case, the miners will be the one who lends their computers and smartphones computing power to the super users of Tau Chain who needs more computational resources, like institutions and university research, to do their projects like protein folding and so on? As what I remember, in this case, miners in Agoras will be paid equally to the work they have done. Unlike to the existing smart contracts where miners need to be lucky. I might be wrong and just trying to visualize the scenario in the future since this is not yet implemented.
There is a difference between the lottery, call it so, of hashing in blockchain and the execution of smart contracts. In current blockchain networks, the miner has to do both, and the nodes have to verify both. But in principle, those are two different things. The hash lottery is designed in such a way that the average time between blocks is constant. Like in Bitcoin, 10 minutes per block on average. And achieving this time ordering is independent, in principle, on whether the execution of the contracts was correct or no. obviously, in networks which are not proof of work, like proof of stake, you don't have this hashing lottery, but you still have to execute the smart contracts. On Tau, execution of smart contracts will be converted to a sequence of BDD operations, and those BDD operations can be done by anyone in the network, possibly for payment. And such a computation can be trusted efficiently by anyone else in the network. If the network will be proof of work, then the hash lottery will have to stay the same. But we expect the blockchain being self-amending and decided by the users. So the users will be able to move, let's say, from proof of work to any other method. And execution of proper computational task, not the hash lottery, will be just one use case of the BDD computational network that can be used for this purpose or for any other computational purpose.
All right, thank you very much, Ahad. And the next question is from Andrew, and they ask, what is the purpose of the transformed tab in the TML IDE?
The tab transformed displays or shows the TML program, which after transformations, because when you run TML program, there are several transformations which are running in the background, and then in this transform tab you can see the result of these transformations. So, and these transformations are for optimizations, or they enhance TML for some features which are not in TML without this transformation.
Fantastic. Thank you so much, Tamash. And the next question is from Sam. And they ask, with Tau having its meta language, TML, a compiler used for Tau's Internet of Languages, will it be easier to onboard developers to build on Tau over something like Haskell, for example, due to the ability to translate between languages developers are already familiar with and into a language compatible with Tau?
To translate a programming language to Tau is a delicate matter, because the Internet of Languages and Tau are meant to be used for knowledge representation languages and not for traditional programming languages. However, I cannot guarantee that this is impossible. We will have to see. Maybe it will be possible to some extent.
All right, and that is it for the Q&A questions for this month. Thank you so much. There are a lot of them. Please keep them coming, and we will see you next month for more Q&A questions. Now we will move on to the business team update. So without further ado, I'll pass it over to Carolina for her update this month.
Thank you, Fola, and hello, everyone. So this month we've been in the process of scouting a web design agency that could create the next iteration of the Tau website. So sort of the dream website that is in our heads at the moment, and we need someone to put it into the real world. And we had several calls with different agencies, and we're now narrowing the list down and discussing how to proceed in the most efficient way. Our goal is to find a team that would both showcase a really strong portfolio, but also someone who would be able to understand and to visualize the complex concepts of Tau. So we are still on the lookout, but we have several options to choose from. We've been discussing and sketching the Tau visual language and storytelling ideas internally with Fola, with Kilian, with Igor. So everyone's having a go, and it's constantly on our minds, and we're constantly working on that. On a more day-to-day basis, we've been implementing the feedback for the current website content, and the front end is being developed as we speak. So it should be online next month. just today we had a call with Oad and Jamie and experimented with walking through this idea maze concept, which led to gathering very interesting angles and ideas for future project communication. So thanks to Jamie for setting this up, and there are a lot of ideas we're going to be communicating in the near future. So that's my quick update. Thank you.
Thank you so much, Carolina. All right, I'll move on to Killian for his update this month. Killian, take it away.
Yes, thank you, Fuller, and hi, everybody. So this past month, we've been working on some pitch deck refinements. So pretty much already leading, like going into the month, we already had a very in-depth version of the pitch deck, which was around 45 pages in length. And I've basically started crafting different decks for different audiences. So, for example, with Fuller, we had a call with a marketing proposal from a university, and from that we kind of got the idea that we also need to start building partnerships with certain projects, especially in the blockchain space, just to strengthen our position in the blockchain field and find the right allies to collaborate with. And basically we figured that we were thinking, okay, what can we offer to different blockchain and DAO projects? And the problem that blockchains today and DAOs today have is in particular their governance models. And we figured that we can offer through Tau decentralized governance for these kind of projects. And then within that scope, instead of basically pitching, or when approaching such projects, instead of pitching them the full Tau pitch of 45 slides, which always takes a good 40 minutes to pitch, we thought, okay, we can craft a pitch that is more oriented or directed to these kind of projects. So I've spent time doing that, and then Jamie introduced us to a project. It's called DeSci. It's a project for decentralized science. Basically, it's a decentralized registry of research papers. And yeah, we pitched them Tau also within the scope of trying to form a partnership on that matter. And what such registry would benefit for, not sure what the right word here is, but it would definitely be good for such a project to have all these research papers formalized over Tau. Yeah, because first of all, that makes the knowledge truly accessible to people. You don't need to search for the right research paper that helps you in your own research. You can just basically then ask Tau for the right input. And once the more research papers are formalized over Tau, the easier it is also for scientists, for researchers to find the right knowledge they need in order to drive further their own research. So having a collaboration, a partnership with this project would certainly be really valuable for both sides. And yeah, this is just the start of this. And we plan to, in the upcoming months, to interact more with them and see where this partnership basically go. I mean, at this stage, it's not really partnerships, it's just we get to know each other. Yeah, then I've been following up. We have a really good candidate there, and we got a proposal by them. So now it's just basically deciding, okay, which of our pitch deck versions do we want to have him design. And yeah, then soon we should have like a really good presentable pitch deck. that is also well designed. And then I've applied to present Tau at 2 conferences. One is the European Blockchain Convention, and the other one is the Paris Blockchain Summit. So far, I don't have any response from them, but hopefully we'll be able to present there. And beyond that, I've just done a bit of outreach to a professor whose focus is on the connections between logics and automata. And yeah, hopefully he'll be also interested in Tau. It's been not that easy trying to get a hold of him. So yeah. And last but not least, the community member of the month, once again, is Andrew. Thank you, Andrew, for your great work. If you look at Andrew's YouTube channel, he has been consistently coming out with videos on TML, even more so this month than in the previous month. So that's really great to see. And yeah, thanks.
Fantastic, Killian. And from my side, I've been mainly working on the compliance and the pitch deck. The website is actually pretty much done. There's just a few slight changes we need to make on the copy. I'm just looking at the compliance on the website because we still need to make sure that we basically cover the US visitors to the site and make sure that certain aspects of the site are off limits to them, basically because we haven't got the US legal memorandum that we work on now. So I'm just been mainly working on that compliance side of things for us to launch the site. It's actually really pretty much ready to go, and just to really dot some I's and cross some T's on getting it out there. So the site is practically ready. Yeah, so it's really exciting to have this version done. And as we have written this version, we've gotten better and better at explaining Tau in as short a time as possible, and that's continuing to that time is continuing to decrease. So we find ourselves explaining Tau, very quickly to outsiders who engage with us and we speak to in conversations for various things. So we hope that the site explains Tau as clear as possible and as quick as possible. And even with this version, we've already got future versions that are quicker. So we're going to launch this site, and then probably within the next month, we'll probably have another site that goes out there. So take it with a grain of salt, but also give us your feedback and thoughts and advice on how we can improve it and what you understood from this site. So we'll be looking out for all your information on that one. So that's extremely useful. So yeah, that is it from the business team. What we're also going to be doing as well, as I mentioned before in a previous Q&A question, is working on something which is a bit more of an overview for the whole project. So I think that will be coming in the next month. So you guys can just follow that if you want to just get like a bigger overview, or you can follow this type style video where we go individually into what we've each been working on. All right. Thank you so much for joining, and we will see you on the dev update. Cheers.